This question, number 24, 6 element, and we know x1 is different from the minimum. Okay, and x6 is different from the maximum. Okay, all right. Our goal, we need to find some element, yeah, let's say x among the array such that x not equal to min and x not equal to max. All right, yeah, the goal. And this question closely related to one of our questions in the quiz. Can you remember? Yeah. Question 9 of quiz 1 or quiz 2? Quiz 1, right? Yeah. Question 9 of quiz 1. Yeah, I remember. So look at quiz 1, question 9. Okay? Yeah. In that one, although we use 1,000 elements, that answer is we can use 3 comparisons. To find an element. Yeah. Different from min, different from max, you know, among 1,000 elements. Yeah. This large number, we just need 3 comparisons to find, you know, such element. Yeah. And here we reduce from 1,000 to 6. Okay. Reduce from 1,000 here 6. That means we can, you know, we have a solution. Yeah. The solution may not be the best. Yeah. We have a solution with 3 comparisons already. Yeah. Just the same way we did in this quiz question. Okay? Yeah. But because in that old question, where we do not have the information x1 not the minimum, x6 not the maximum. We do not have that information. And this question, we have more information. So then our solution should be better than this 3 comparison. We are looking for a better solution. Yeah. If not better, then we just take old solution, right? Yeah. The better it means we should use fewer number of comparisons. Yeah. For that reason, for that reason, here we target 2 comparisons. So our goal here, we want to use 2 comparisons to get a solution. Okay, all right. Yeah. Next question, how to do it? Yeah. How to do it? Yeah. You need to take advantage of the given info because this given info is valuable here. Okay? Yeah. You should not throw it away. So what is the given info? That means the minimum already less than x1 and x6 already less than the max. Without comparison, you already have these two inequalities. Yeah. Next, you just need to complete the remaining part. Yeah, because the given information only gives you the partial information you need for the solution. You need complete the remaining part by two more comparisons. Okay? Yeah. Yeah. So you have to, when you use two more comparisons, you have to use them in a wise way, smart way. Yeah. Do not waste. Yeah. Those two comparisons are very precious. Do not waste them. All right. Yeah. Here, for example, because for the first comparison, then we have some freedom, right? Yeah. Because the second comparison is very important. But the first comparison, yeah, we have some room. Yeah. So the first comparison, yeah. So we can pick x2, right? Yeah. We can pick x2. Yeah. x2, 3, 4, 5. Yeah. Any one of the four, because we have no information for these four elements. Yeah. Here we just pick x2. Yeah. After we pick x2, we can compare it with the special element x1 or x6. Yeah, just compare with one of the two. Yeah. Okay. Yeah. So first compare it. Yeah. Here, let's say we compare with x1. Okay. Yeah. The first comparison, compare it with x1. So you have two cases, right? The first case, x2 less than x1. Second case, x2 greater than x1. Yeah. Because here I assume distinct elements. So do not consider the equal case. Yeah. x2, oh, you only have these two cases. No more than these two. Okay, all right. So which one is easier for us? Easier for us to get solution. Yeah, look at that. If x2 greater than x1, can we get a solution? Because combining with that one, you will get a minimum less than x1, right? But you also get x1 less than x2. Can you get a solution after that? Right? Yeah. If you get a solution, that means only one comparison you can get a solution. You do not need two. You just need one. Okay? Yeah. But in this case, definitely x1 is, you cannot say x1 is solution because x1 greater than x2 greater than minimum. But you do not know if x1 is less than the maximum, right? Yeah. So this one, you need the second comparison. Yeah. And this second comparison, you should use it in a smart way. Okay? Yeah. But when you use second comparison, you can assume x2 is less than x1. So this information is useful. Okay? Yeah. So you take it, you put it aside, Then yeah, you try to design your second comparison. Your second comparison is very important, very precious. Do not waste it. Okay, all right. But here I do not tell you how to do the second comparison because that's critical. That's the same thing as telling you the answer. And I do not want to tell you the answer here. Yeah, you need to find it by yourself. Okay, but I tell you one important guideline. One important guideline. Okay, when you do the second comparison. Okay, yeah. All right. So the guideline for second comparison. Okay. Do not touch any of these three elements, x3, x4, x5. Do not touch any of these three elements. Yeah. The reason is simple. Yeah. I hope I have more space here. The reason is very simple. Because those unknown elements, if you touch, you waste your precious last comparison easily. Yeah. You don't want to waste it. Yeah. So you want to spend your precious last comparison on these three elements with known information. Yeah. Yeah. So spend your last on, yeah, I cannot write too many words, on x1, x2, x6. Yeah. Then one comparison, you can get enough information for the solution. But if you touch some unknown element, yeah, x3, x4, x5, any of the three completely unknown. So one comparison is not enough to know that unknown element well. Okay? Yeah. You just waste that precious one comparison. Do not touch any of them. Yeah. Spend on that last chance on known elements. Known elements. That's the guideline. How to, then you need to make it. Okay? Yeah. So with this information, then you need to complete the remaining part. Yeah. That should not be far away. Yeah. Yeah. You should be able to make it with some effort. Okay? All right. That's question number 24. Yeah.